Moving on, example 5 is not much different than example 4. The difference being is that in example 5, we're going to try to find the present value versus finding the future value. So I'm on page 402 of your book. Upon the birth of a child, a parent wants to make a deposit into a tax-free account to use later for the child's college education. Assume that the account has an annual interest rate of 4.8% and that the compounding is done quarterly. How much must the parent deposit now so that the child will have $60,000 at the age of 18? All right, so let's start breaking down what we know on this one. So in this case, the A value is known. We want it to be $60,000. P value is unknown. If you need to put that on here and put a question mark by it, you certainly can. There's nothing wrong with that. The R value is also known value. They tell us it's going to be 4.8%. So 4.8%, but again, we don't want to use that as that. We want to use it as 0.048. Again, if you need to divide it by 100, there's no shame in that. That will give you the exact decimal that you need. Time, well, the child's going to be going to college in 18 years from birth, so 18 is that number. And then the number of times it's going to compound. They tell us quarterly. How many quarters are there in a year? How many quarters are there in a dollar? There's 4. Once we've defined all of our parts of this, we can now set up the problem to solve. 60,000 is our A, so 60,000 equals. Principal we don't know. 1 plus the R value is 0.048 divided by 4, that's our N, to the power of 18, that is the time, times 4. Again. All right, beautifully. Now we'll bring up our calculator. And again, this is going to be part 1. We're going to do this first. Then we're going to add 1. That'll be second. Then we'll take it to the power over here. That'll be 3. And then we're going to stop because we're going to have to set that up so that we can now solve for P. It's not quite as straightforward as the last one because we do need to divide at some point here. But let's at least get this part down so we have the number there and we're ready to go. Now we can clear off anything that may have been there before. Let's give ourselves some space. We know what we're calculating here. All right, here we go. We're going to take 0.048. We're going to divide by 4. And hit enter. Get that number. Then say plus 1. Get that number. Then raise it to the power of 18 times 4. All right. So right now we've got this 2.3604. And it's not a bad number to have, but because the decimal doesn't end, what we can do is we can actually step back one level and we can say this. We can say that 60,000 is equal to P times 1.012 to the power of 18 times 4. All right, that'll be good enough for now. We don't want to put the other decimal in because if we put the entire decimal in, at this point on our page, 1, I'm not going to write that many decimal points out, and 2, if we round it, we're going to lose something. So we'll just go back one step here, and we'll say, all right, this looks pretty good, because right now we've got to divide both sides by this 1.012 to the power of 18 times 4. Now some of you may say, isn't that the same as 72? And that's fine. We can make that 72 to look a little bit nicer. 18 times 4 is 72. And then we need to divide this side too by the same amount, as in 1.012 to the power of 72. And now it's calculator ready. Now we can figure out what our principal is going to be in just a second, because we're going to take 60,000 divided by 1.012 to the power of 72. All right, so let's bring our calculator back up. All right, we don't need that. Let's go ahead and clear that one off. We don't need that for the moment. And we'll say 60,000 divided by, now we're going to put a parenthesis in here. We're going to put in 1.012. We're going to end our parenthesis, and then we're going to raise it up to the power of 72. And if you don't like that, you can always do 18 times 4 as well. It'll work the same way at that point. And then we're going to hit enter, and the magic is going to take over. And it tells us that we're going to need to save roughly $25,418.76. So let's translate that to our paper here, our virtual paper. So $25,418.76. So pretty precise, the 76 cents. You know, you might, if this was your son or daughter going to college, you might kick this into 419 or maybe even just make it a 420 to ensure that, you know, you had the $60,000 it was going to take. But precisely, it is $25,418.76.